Hello, grade 11 STEAM learners. Welcome again to our new lesson, which is all about formulas and names of compounds. But this video and audio presentation will only focus on writing of formulas. Separate video will be presented on the naming of compounds or nomenclatures. So the most essential learning competency of this lesson is to recognize the formulas of common chemical substances. The targets are the following: name and write the formulas of binary compounds using the periodic table. Name and write the formulas of compounds given some common polyatomic ions and active metals, and explain the significance of naming and writing formulas of compounds. But this time, we will only be tackling on the significance of writing formulas of compounds, while on the next video, we will be focusing on the naming of compounds. Let's analyze the picture first. What is the picture all about? Why? Which substance is being represented by that structure? Clue: it is the universal solvent. What is the formula of that universal solvent? Explain your answer. You are right. That molecular structure represented by a water, H2O, wherein the central atom is oxygen, which is the red color, while the two white in between of the red are the hydrogen atoms. So that structure represented a water or H2O, which is the universal solvent. Atoms, remember class that atoms are tiny indivisible particle of an element. Every element has only one kind of atom. Again, every element has only one kind of atom. Atom is neutral or no net charge. Example is oxygen, hydrogen, and more other elements. When we say molecule, it is an independent structure consisting of two or more atoms chemically bonded together. So when two or more atoms are chemically bonded together, and that will be called molecules. Atoms in a molecule are held together by a covalent band. When we say covalent band, it is a band of non-metals, composed of non-metal atoms. Neutral also, which means there's no net charge. Example is O sub 2, which is oxygen gas, and H2O or water. What is ion? Ion is formed when an atom or molecules gains or loses electrons. Ions can be monoatomic or polyatomic. When we say monoatomic, it has only a single atom, while polyatomic, which is which are two or more atoms, composed of two or more atoms. Ion has positively and negatively charged. Example, Na plus or sodium positive, and hydroxide or OH negative. Classify each of the following as an atom, molecule, or ion. First, we have helium. It is an atom. Nitrogen gas. It is a molecule. C12H22O11, which is your table sugar, is a molecule. CO, or carbon monoxide, is a molecule. And Mg2 positive or magnesium 2 positive is an ion. While your ammonia or NH4 positive is also an ion. Your phosphate, which is PO4 3 negative, is anion. Try to check your periodic table, as I've mentioned a while ago, that you will be going to memorize the atomic number, the elements, and the symbol of your periodic table, which is composed of 118 elements. Make sure to familiarize the composition, the properties, at the same time, the blocking, and the periodicity of your periodic tables. Remember that periodic tables are divided into three blocks. You have the metallic or metal block. You have also the metalloids and the non-metals. Remember that the last part, which is the group 18, are your gases or noble gases. They are noble gases because they're having a stable valence electrons. But we will be having a separate discussion on periodic table on the electronegativity, um, electron affinity, electron size on our next lesson. Chemical formula is a way of representing information about chemical proportions of atom, which is usually done by a subscript. This subscript, usually seen at the lower right part of the symbol, that indicates the number of atom of that element. Aside from elements, symbol, we can also use numbers and sometimes other symbols like parentheses, dashes, brackets, commas, and plus and minus signs. It is very important to use a chemical formula to represent information of a certain chemical proportions of an atom. Why? Because if you are not going to use a chemical formula, it becomes complicated on how to identify the number of atoms in a given compounds. Remember that ionic compounds, when we say ionic compounds, it is a band or it's a compound that forms between metals and non-metals, composed of a cation and an anion that are held together by ionic band. When we say cation, these are the positive charge. Cations are the positive charge. The anions are the negative charge. Generally composed of a metal and non-metal, as what I've said earlier. Metals tend to lose electrons to form cations. In order to form a cations, metal tend to lose their electrons, while the nonmetals tend to gain electrons to form anions. So they will gain electrons from metals to form anions. Binary ionic compound contains monoatomic ions of two different elements. Example, sodium chloride or Na positive and chloride or chlorine is negative. Remember, it's a binary ionic compound because it composed of monoatomic ions. Mono means single atom only, but of two different elements. So what is the cation here? We have the sodium. And what is your anion? We have the chlorine. If you see this, the charge or the sign superscript at the top of a element symbol, that is immediately an ion. While if you see a positive, it means a cation. Remember that ionic compounds composed of a cation and an ion that are held together by ionic band. So they're generally composed of a metal and non-metal. If you see in your if you look back again in your periodic table, those metal elements can be bond or can be combined or can be form a compounds from non-metals. If we form the metals and non-metals, the formation or the combination or the compounds that will be formed is what we call ionic compounds. Steps in writing chemical formula. First step, write the formula of the cation and the anion second. First, you have to write the formula of the cation, or which is called the metals, and the anion second, or the non-metals. Number two, use the crisscross method to balance the charges that I will show you later. Third, reduce the subscript of the cation and anion to smallest whole number ratio if necessary. So in order for you to get the number of atoms correctly, you have to reduce the subscript into a smallest whole number ratio. But if there's no, if we could no longer reduce the whole number into smallest ratio, therefore that is already correct. But I mind you, class, way back when we were in college, as I told you earlier, that even without reducing into smallest whole number ratio, the atom still correct. But now, as agreed by the IUPAC, you have to reduce the smallest whole number ratio if necessary. Shown in your screen are the common monoatomic ions. Again, this is common monoatomic ions. Monoatomic means one atom only. You have the cations, name, hydrogen, H plus. You have the lithium, Li positive, sodium, Na positive, potassium, K positive, magnesium, Mg2 positive, calcium, Ce2 positive, and aluminum, El3 positive. How about the anions? Remember, I'm talking about the cations or the positive ions. When we say anions or negative ions, we have the hydride, H negative, nitride, N3 negative, oxide, O2 negative, fluoride, F negative, chloride, Cl negative, bromide, Br negative, and iodide, I negative. These are also the common polyatomic ions. When we see polyatomic, a composition or a combination of two or more atoms. So we have in each four, or the ammonium ion, which is positive charge, hydroxide ion, which is negative charge, or your OH negative. You have the nitrate ion, or NO3 negative, bicarbonate ion. We have HCO3 negative. Then you have the carbonate ion, or CO3 negative 2. Sulfate ion is O4 negative 2. And phosphate ion, PO4 negative 3. Example number 1, we have calcium chloride. Remember the steps you have. First step, you have to write the formula of cation and the anions. What is the formula of calcium? You have Ca2 positive, and the chloride is Cl negative. As much as possible, you have to memorize the monoatomic and the polyatomic ions in your periodic table. Not necessary that you have to memorize, but if you could memorize, it's better. So next step, you have to crisscross method. So crisscross the cation, which is the calcium 2 positive, and the chloride, which is negative. So the atoms will transfer from cation going to chloride, or from calcium going to chloride, from chloride going to calcium. The result will be Ca, or calcium sub 1. 1 means the negative, understood to be having one atom. Then the Cl2, which is the atom or the charge coming from calcium. That was received, or that is received by chloride. Net charge is equal to, let us check the net charge. You have 1 from calcium received from chloride, but the calcium has 2 positive charge, plus you have the atom of chlorine or chloride received from calcium, which is 2. Then you have multiplied by the original charge of chloride, which is negative 1, is equal to 0. Remember, as I told you, that the net charge of this compound should always be 0. So the correct formula is CaCl2. Sir, why is it that the Ca1 was lost? 1, or Ca stands for 1, understood to have one atom. So you don't need to write the one atom. Again, the correct formula is calcium chloride is CaCl sub 2. Number 2, magnesium oxide. So write the formula of magnesium. You have magnesium 2 plus as your cation. The oxide, which is your anion, O2 negative, crisscross, The result is Mg sub 2 O sub 2. Let us check the net charge. You have 2 multiplied by 2 positive plus 2 multiplied by 2 negative, you have 0. The correct formula is MgO because you have to reduce the whole number into you have to reduce the atoms or the number of atoms into a lowest term. So you can make it 1:1 ratio. Okay? The number, let's just try this following uh, compounds. Directions: write the chemical formula of the following binary ionic compound. Number 1, potassium iodide. Number 2, aluminum oxide. Number 3, aluminum nitride. And number 4, potassium oxide. Try to answer it in your scratch paper. You're given at least 1 minute to answer these four compounds. Okay, time is up. Let us check your answer. You have potassium, for potassium iodide, you have potassium symbol or formula is K positive. Then the iodide, we have I negative. So crisscross method, you have, the answer is Ki I. How about for the aluminum oxide? You have El, 3 positive, and O2, that is negative. So crisscross, you have El2O3. How about for aluminum nitride? You have El3 positive, then N3 negative, or nitride 3 negative, crisscross. You have El sub 3 and sub 3. So is this a final answer? No. You can reduce it to lowest term. So the answer will be ELN. You have potassium oxide. We have Ki positive for potassium. When the oxide is 2 negative, crisscross, you have Ki sub 2 O is the correct formula for potassium oxide. Now, you will wonder how we are going to find again the charges of the cations. If you go back to your periodic table, you can find it at the top of each element, at the column of each element. You can find it there. Let's go back. Let's go back in the periodic table. Okay. As you can see, sodium, you can find it here at the top. It's under 1. Okay. 1A. So 1. It means it has positive charge 1. Okay? Then you have magnesium. So you have 2 positive. Okay? For calcium also, you have 2 positive. Okay? Here for chlorine, why 7, sir? You have to minus from 8 minus 7, automatic you have, or 8 minus 7, you have negative 1. So for oxygen, 8 minus 6, you have 2 negative to become oxide. Okay. So let's go back to our discussion on um, the other type of writing. So let's move on to binary ionic compounds with metals. The one we have discussed is also the one we have discussed a while ago. It's also a binary ionic compounds, but using but in a monoatomic compounds. Or this time, we will discuss binary ionic compounds with metals that have different charges. Metals that have different charges. These metals contain a Roman numeral which indicates the charge of the cation. So what are the Roman numerals? We have the iron. You have iron 2, iron 3, copper 1, copper 2, cobalt 2, cobalt 3. Then you have tin 2, tin 4, lead 2, lead 4, mercury 1, mercury 2. So those Roman numeral next to the name of an element represent the number of cations. So if 2, kung makita ninyong dalawa, ion 2, automatic, it is 2 positive. Kung nakita ninyo lead 2, automatic, it is Pb2 positive. Steps is the same. Actually, steps are the same with the previous one we have discussed. But again, for the information of everybody, again, I would like to read it. The steps are write the formula of the cation and the anion second. So always write the formula of the cation and the anion, which is the second. Next, use the crisscross method to balance the charges. Always remember to use the crisscross method. Then reduce the subscript of the cation and anion to smallest whole number ratio if necessary. Again, the subscripts represent the number of atoms. Example number 1, you have iron 2 oxide. So you have to write the formula of cation, which is the iron, and the oxide, which is the anion. You have if A or the iron is 2 positive, while the oxide is 2 negative. So crisscross method, then you got if A sub 2, O sub 2. The correct formula is if A, O, because you have to reduce it to lowest ratio. Okay. Number 2, iron 3 oxide. You have Fe3 plus for your iron 3. 3, numeric 3 represent the number of 3 charge, positive. Then the oxide, which is 2, negative. Crisscross. Then you got Fe sub 2, O sub 3 again. The 2 atom received from by iron is from the oxide, which is 2 negative charge, while the O sub 3 receive the 3 from iron, which is 3 positive. The correct formula is if A sub 2 O3. Is this the lowest possible term? Yes. That is already the lowest possible ratio, 2:3. Let us try this one. Directions, write the formula for each ionic compound. Number 1, copper 2 chloride. Number 2, manganese 4 oxide. Number 3, iron 3 bromide. So you have for copper, Cu2 plus, then Cl negative, the formula. So crisscross, you have CuCl2. For manganese oxide, you have Mn4, 4 positive because you have 4 numeric next to the element name. Then you have the oxide, which is 2 negative. Crisscross, you have Mn sub 2O4. Then reduce to lowest ratio or lowest term, you have MnO sub 2. For iron 3 bromide, you have if A3 positive, then Br negative. Crisscross, you got it if A Br3. Okay. Let's move on to ionic compounds with polyatomic ions. So when we see polyatomic ions, these are composed of 2 or more atoms. So cation and anion are either or both polyatomic. So maybe ang cations polyatomic siya or pwede rin ang anion polyatomic or both pwede sila polyatomic ions. So example of common polyatomic ions, you have the ammonium in each 4 positive. Okay? So this is a polyatomic cation because of the positive charge. See, why polyatomic ions? Because in each 4 composed of how many number of atoms? You have 5 atoms. So plus the positive charge, then you have mercury, Hg, 2 positive, Hg sub 2, 2 positive, hydroxide, OH negative. This is now the anion, polyatomic ions, or polyatomic anions. Cyanide, Cn negative, peroxide, O sub 2, 2 negative, nitrate, Na, NO3 negative, acetate, C sub 2, H3O2 negative, permanganate, MnO4 negative, carbonate, CO sub 3, 2 negative, sulfate, AceO4, then 2 negative, dichromate, Cr sub 2, O sub 7, superscript 2 negative. Phosphate, you have PO4, 3 negative. Steps in writing chemical formula for this one, still the same process. Write the formula of the cation and the anion second. Then you have the use the crisscross method to balance the charges. Then reduce the subscript of the cation and anion to smallest whole number ratio if necessary. Example number 1, you have calcium carbonate. Ca2 positive, which is the calcium. Then the carbonate, we have CO3, 2 negative. Remember, the carbonate now is your polyatomic ions. Polyatomic anions because it is 2 negative. So crisscross. Then you have Ca sub 2, close and open parenthesis, CO3, then 2 at the close and open parenthesis. So note, if the subscript of the polyatomic ion is 2 or greater, again, if the subscript of the polyatomic ion is 2 or greater, the ion must be enclosed in a parenthesis. Pag dalawa na or more than dalawa na, ang subscript ng polyatomic ion, kailangan mo na siyang i-enclosed in a parenthesis to segregate the proper number of atoms in each ions. So the correct formula will be CaCO3. Bakit? Because the calcium, we have 2 number of atoms. CO3, meron ding dalawang number of atoms. So you have to reduce it into lowest term. Therefore, 1:1. So CaCO3 na. Next, you have sodium hydroxide. You have Na positive, the sodium, which is your cation. Then the hydroxide, which is your negative polyatomic ion or anion. You have OH. Cross, you have NaOH. Note, if the subscript of the polyatomic ion is 1, the use of parenthesis is no longer required. So it's no longer needed if the subscript of the polyatomic ion is 1. Like for example, here in the sodium hydroxide, the subscript of the polyatomic ion, which is the OH, is only having 1. So therefore, no need to put or no need to use a parenthesis or, yes, a parenthesis. The correct formula is NaOH. Let us try this, directions. Write the formula for each ionic compound. Number 1, ammonium chloride. Number 2, sodium phosphate. Number 3, ammonium sulfate. So you have for ammonium chloride, you have NH4 positive. Your ammonium formula is NH4 positive. It is a polyatomic cation. Then the chloride is Cl negative, cross. So you have NH4Cl. Remember, we didn't put the parenthesis of NH4 because it has only one atom received from chloride. So if one, no need a parenthesis, okay? For sodium phosphate, you have Na positive, the sodium. Then you have phosphate, PO4, 3 negative, cross. So you got it, Na3PO4. Again, you don't need a open and close parenthesis to a cation, which is a single ion or a monoatomic ion. Okay, monoatomic kasi ang sodium. So hindi mo na siya kailangan lagyan ng close and open parenthesis. Ang lagyan mo lang ng close and open parenthesis ay yung polyatomic ions na may more than two or more number of subscripts or your atoms. Then you have ammonium sulfate in each 4 positive and the SO4 2 negative. Cross. Then you got it. In each 4, close and open parenthesis, sub 2 is O4. All right. Now let's move on about the covalent compounds. We have already discussed about the ionic compounds. This time we will discuss the covalent compounds, the writing of formula. These covalent compounds is also called molecular compounds, composed of atoms that are held together by covalent bands. So when we say covalent band, mostly composed of non-metals. So pag non-metals, automatic covalent band or covalent compound siya. Pag metal and non-metal, that is ionic compound. If metal to metal, that is metallic compounds. Binary covalent compound contains two different non-metal elements. Uses prefixes that indicate number of atoms. So to indicate the number of atoms, you will use a prefixes. Examples, CO sub 2 or your carbon dioxide. Remember that the di is your prefix for oxygen. Okay, because why? Because oxygen here has two number of atoms and 2 indicates di as your prefix. Therefore, you will call it as carbon dioxide. Remember these prefixes used in binary covalent compounds. You have prefix mono, which means number of atoms indicated 1. Di, number of atoms 2. Tri, number of atoms 3. Tetra, number of atoms 4. Penta, number of atoms 5. Hexa, number of atoms 6. Hepta, number of atoms 7. Octa, number of atoms 8. Nona, number of atoms 9. And deca, number of atoms 10. Step, you have to write the formula of the first element followed by the second element based on the prefix used. Example number 1, nitrogen monoxide. So nitrogen is N, then the oxygen is O. So monoxide, mono means 1. Therefore, we will not write anything, only 1 or single symbol O. The answer is NO. Example number 2, you have carbon tetrachloride. So what is the formula you have for carbon? C, and for chloride or chlorine, you have Cl. Then put the number of atom which is 4 or tetra. Kasi ang tetra 4, di ba? So lagyan mo yung subscript ng chlorine 4. So try this one. You have phosphorus pentachloride. You have sulfur dioxide, dinitrogen monoxide, dinitrogen trioxide. So you have for phosphorus pentachloride, you have P for phosphorus, chloride or chlorine, Cl. Penta means 5, so you have to put the number of atom which is 5 or penta. Sulfur dioxide, S for sulfur, oxygen or oxide is O. Then you have di, which means 2. Dinitrogen monoxide, you have N2O. Dinitrogen trioxide, N2O3. So that's all for today. Just wait or just check for the other video on the naming of compounds or nomenclature.